Hello everyone and welcome. This is a tutorial video of volume meshing using the Map Block tool in ANSYS. The initial complex 3D geometry will be systematically broken down into smaller, more manageable structured blocks. This systematic decomposition will facilitate the generation of high-quality, structured hexahedral mesh. If you'd like to explore a more detailed explanation of the map block basics, check out the Getting Started video linked in the description. In this session, we will demonstrate the efficiency of the auto-split function across different directions within a model that presents complexity and a variety of features. We will review the available methods for defining the splitting and identify in which case each method is more suitable to use, depending on the geometry at hand. We'll also highlight the importance of manual intervention, when necessary, to assist the Map Block tool in achieving proper mapping of the volumes, especially in challenging areas. And finally, we will see how independent volumes of different connectivity groups behave when they are within the same model. Let's begin with a brief overview of the model we'll be showcasing. The model appears to be a mechanical assembly with multiple components. It consists of two parallel slabs connected by a section featuring fillets and chamfers. The bottom slab features three vertical holes along one edge. Two parallel cylindrical supports extend vertically and penetrate the bottom slab, without forming a continuous connection to the model. They belong to different connectivity groups and are independent. The model has three distinct volumes: the two cylinders, and a third volume that includes the remaining parts. A third support is inclined. This inclined support has a recessed base, passes through the bottom slab, and continues up to the top. At the front of the two slabs, there is a rectangular frame featuring hexagonal holes on all four sides, in horizontal and vertical direction. The frame is connected with the slabs through an inner wall with a rectangular cutout in the middle. On the top slab, there is a counterbore with an external ring, a discorectangle groove, and a cylindrical structure with an attachment bracket on top, and four holes. Due to its complexity, it will need to be broken down into more manageable sub-blocks, using both automated and manual splitting techniques in order to be mapped and meshed. Now that the model has been described, the process of mesh generation will begin. Activate the Define Map Block function from the Volume Mesh ribbon tab. Select the entire part in the drawing area using the left mouse button and confirm with middle click. The two cylinders, as separate connectivity groups and closed volumes, are recognized as mappable and are highlighted in green as ready to mesh, whereas the rest of the model is characterized as non-mappable. The Map Block function detects and maps individual parts that are mappable, even if the entire model is not yet ready. A warning message will appear, indicating that the part's volume is non-mappable and requires further decomposition. Click OK to open the Decompose ribbon tab. The ready sections are concealed, allowing the user to focus solely on the remaining areas that require further refinement. The complex volume must be divided into simpler closed subblocks to be suitable for meshing. Activate the Auto Split function from the Decompose ribbon tab. To begin with, we can search for splits in the X direction to start forming closed volumes in the bottom slab and the rectangle frame at the front. When the splitting direction is not obvious and the vector cannot be manually specified by setting the coordinates, there are several methods to define the split direction. Click on the arrow in the 2 points tab in the Definition section to see the available options. Depending on the geometry and context, you can define the split direction along a straight line between 2 points, perpendicular to a plane, or along a curve's tangent. The tangent option sets the split direction, based on the tangent direction on the edge of a selected curve. Click the arrow next to tangent, select a curve, and the system will preview the tangent direction at one of its edges. The edge displayed for the preview depends on the proximity of the click. The side of the curve closest to the point where the selection was made will be used. For straight lines, the tangent direction remains constant at all points along the line, as it aligns with the direction of the line itself. Select the outer upper left con of the front frame as shown. The split vector is automatically updated to 100, as the con is a straight line oriented in X direction. Click Preview to see the proposed splits. At this stage you can choose to deactivate splits to prevent them from being created. Right-click and deactivate the proposed split as shown. Click OK. The generated splits form mappable closed volumes. Hide the non-mappable volumes to view the mappable ones in green. Show only the non-mappable to continue. Keep in mind to hide the ready-to-mesh parts after every split, to focus on decomposing only the non-mappable section. Splits in the Y direction are necessary for decomposing the hook and subdividing the frame into slabs. Activate Auto Split, and manually set the vector to 010 to specify the Y direction. Enable the Both Sides option to search in both positive and negative directions. Preview the proposed splits. Click OK. The front frame and the top bracket volumes have been decomposed. Hide the ready-to-mesh volumes. In the remaining part, the cylinders and the holes on the top structure are oriented in the Z direction, as are the wall of the groove and the counterbore. Extending their cons in the Z direction can facilitate decomposition. Switch to the left view to see on a different perspective the model, for a better visualization of the feature's orientation. Activate Auto Split and select 3 points definition. Click on the arrow icon and select 3 points in the upper slab as shown. In this method, the resulting vector is perpendicular to the plane formed by the selected points. The direction of the vector follows the right-hand rule, meaning its orientation depends on the order in which the points are selected. The previewed vector is displayed at the first selected point for reference. Confirm with middle click to set the positive Z direction. The Both Sides option remains enabled, as Auto Split function retains the parameters from the previous split. Click Preview. The function detects splits in the chamfered part, the ringed hole, the groove, and the central cylindrical structure with the holes. In the inclined cylinder, the proposed splits do not align with the cylinder's inclination. We will cancel this specific split. You can either deactivate or delete the proposed splits. Deactivating temporarily hides them, but allows reactivation, while deleting removes them permanently. Click OK. Hide the ready-to-mesh generated volumes. For the inclined support, the split should be oblique and aligned with the direction of the support. Auto Split will be used, with the 2-point selection option to define the split vector, ensuring it follows the direction of the support. Alternatively, the tangent option would be also suitable for this case. In the 2 points method, you select 2 points, and the previewed direction is the one, pointing from the first to the second selected point. Click the arrow icon, select 2 points on the inclined support's con, and confirm with middle click. Preview, and see the extensions on the inside and outside cylinders to create closed subblocks. Confirm the splits. The incline support and the bottom slab are ready to mesh. Hide them. The remaining part is characterized as mappable with errors. Map block has recognized and mapped the volume, but something is preventing it from proceeding. Activate the caps. The way the caps have been recognized makes it challenging for the function to map the volume properly. At this point, the target cap comes into direct contact with the source cap, leaving no space for the function to build the side area. Triangular elements are generated along the sides, which should consist exclusively of quads, disrupting the mesh flow. These triangular elements are colored red for easy recognition. Splitting the two volumes will allow the caps to be defined in independent directions, resolving the issues. Activate the fill function, select the two cons as shown, and confirm with middle click. Update the model. The volumes have now become mappable. The cap orientation has changed in the left volume, placing trios on the caps, while keeping only quads in the side area. Also, this configuration ensures acceptable mesh flow, making the volumes ready to mesh. The mesh on the cylinder, and the walls of the slab's holes, is incompatible as they are independent volumes. Use the compatible flanges function to link their common faces and achieve mesh compatibility. Mesh the model, and view the volumes in PID draw mode, for a better understanding of the final decomposition. This concludes our tutorial. Stay tuned for more in-depth workflows on structured meshing using the Map Block tool. If you found this tutorial helpful, be sure to check out our previous videos for additional insights. Thank you for watching.